Good afternoon, good day, everyone. Thank you for joining our Infoshare on the AI network operations. I'm Ivana Golub, working for PCSS, Polish Research and Education Network. And together today we will have several talks, and first I would like to announce the first speaker who will also give the introduction to this Infoshare. It's Pavle Vuletic from University of Belgrade AMRES. Pavle and myself are leading together the network development work package, which is a part of the GÉANT project, and this work that will be presented during today's Infoshare is result of our project. So Pavle, handing over to you.
Thank you, Ivana. Good afternoon to all the participants of this Infoshare. As Ivana announced, I will say a few introductory words about our activities in Work Package 6, and then we will go to the key topics of today's Infoshare, the presentations from our experts. Work Package 6 in the current GÉANT project is called Network Technologies, and it is about network technology. In the past 25 or 30 years, network management has passed apart from the configuration of network devices using CLI, then through the use of various OSS and BSS tools and software components, then through the automation and orchestration of all these components into one general network management platform. Then came machine learning and the use of machine learning in typically some sort of fault detection and anomaly detection. And then in 2022, what happened is that ChatGPT appeared near the end of this year. This is only 3 years since that moment. ChatGPT became the fastest growing consumer software, and today everybody is talking about the use of AI and the use of generative AI. And this is clearly a new buzzword, and you are all aware of the large investments into new data centers and into the general activities around AI. So this created a sense that something should be done about this, and that we, not just we in Work Package 6, but generally, NRENs should do something about the use of AI in their day-to-day operations. And I believe that the fact that we had almost 120 participants who subscribed for this Infoshare, and that at the moment we have 75 participants in this call, shows that there is this sense that something should be done, that there is a lot of interest, and that people are trying to understand how to use AI in their day-to-day operations and how this can be helpful for their work. One clear line of thought is that if it can write text or code, then probably it can write some network configurations, scripts, and maybe this can be used in our work. So what we wanted to understand, and what we are trying to understand, and what we are working on in Work Package 6 is to see how AI can be used in network management, and you will hear several presentations about that. But what we also noticed is that there are a lot of research activities around this topic, and that you can see that IRTF is creating meetings on AI now regularly every 2 or 3 months. That there are also conferences related to the use of AI in network management, which are happening every month or so. So there is a lot of activities. What Work Package 6 has been doing and is doing at the moment, and what is related to the AI, are several activities. In the previous project, which ended at the end of 2024, we had a chatbot for Network eAcademy. This was a chatbot that was supposed to help the users of Network eAcademy, the students, to find the appropriate courses and to help them in that journey through the Network eAcademy. This work was completed in GÉANT phase 1. And in the current project, which started on 1st of January of the previous year, we have started and completed 2 incubator projects, LogsLLM, which is about the automated log analysis and management based on large language models, and also a module, AI module for workload orchestrator was created in meantime. you were supposed to hear both presentations, but unfortunately, as Ivana said at the beginning of this call, one of our presenters got ill. So we will, you will hear only the first presentation about LogsLLM, and we hope that very soon, in some other event, you will be able also to hear this presentation, because this is also an important piece of work which is related to the AI model for workload orchestrator. In another task, in our task 4, we are working in the Network eAcademy on AI track, and you can see, not yet official, metro map which shows all the course material that we are supposed to create in this project, which is related to the use of AI and various aspects of AI and various models of machine learning, generative AI, and so on. At last, but not at least, we also have the activities in our task 2, which are related on the use of AI for network automation, and this is also a presentation that you will hear today. We have some other activities like persona and PMP data analysis, which is not so much related to the use of generative AI, but more to the use of machine learning in network management data analysis. What we have completed in 2025, in October 2025, is a survey, Intelligent Networks, the Rise of Generative AI in Network Management. And in this survey, the team of our experts has analyzed 57 scientific reports and 39 different tools, both commercially and commercially available and open source, which are related to the use of AI in network management. We tried to somehow classify all these approaches according to the FCAPS, the old FCAPS model of network management. So there are sections which are related to fault, configuration, accounting, performance, and security management. And this document presents a snapshot of the situation as of June, July 2025. We were supposed to stop at some moment and then to create a report. And this report is available, as I said, on Zenodo since October last year. There is a link down there. So if you haven't downloaded the document yet, you can do that, because this presentation is also available on the events page where you registered for this Infoshare. So there you can find the link and you can take a look at this report, which is very detailed and shows various aspects of the use of generative AI for network management. So on the menu today, this was our initial plan to have these 4 presentations and the Q&A session in the end, but unfortunately, because Peter has sent us a message that he is not feeling well, we had to cancel this second presentation. We wish Peter to get well as soon as possible, and as I said, there will be some future Infoshares and events where you will be able to hear this presentation as well. The first presentation today will come from Sonja Filiposka from the University of Kirill and Methodi from Skopje, from Northern Macedonia. And this is the presentation about our work in task 2, from prompts to provisioning. Then you will hear a presentation from Dimitrios Pantazatos from NTUA, from Athens, about LogsLLM incubator project. And the last presentation will be from Isabel Gandía about Network eAcademy AI courses that we are preparing for the next project. So instead of 2 hours that we thought that this Infoshare will last, it will be about half an hour shorter, which is good, I think, for all of us that have issues in getting longer attention time. So yeah, I hope that this is going to be informative for all of you and interesting.
We will start with one of the use cases that Pavle mentioned, from prompt to provisioning. This is something that we have been working on in work package 6 as part of the GPFRL team that currently focuses on different types of solutions for orchestration and automation of network services. Mainly, the thing goes like this. So one of the things that we have been working on in the past is, together with PCSS and Pioneer, the network that PCSS is managing actually, we were trying to develop a generalized orchestration and automation solution for networking services, starting from scratch. So we went through all of the phases, service design, APIs for different components, design of the workflows, choosing and using a single source of truth, and so on. And we already have a solution that is working in production for the Pioneer network in Poland, and it's great. One of the things that came up during the design and the implementation process, when, as Pavle said, ChatGPT came into play and became very famous and seemingly easy to use to also code as well, was the question, could have we used AI to design some of the things that we are doing manually, or maybe implement some of the codes for the workflows and so on? And it's in the beginning, it was posed as a challenge. So I said, okay, let me try and play with ChatGPT and see if I can come up with a solution that is similar or maybe better than the solution that we had for Pioneer. And in order to do this, we basically set up a goal for a mini project that the idea is to develop an AI-supported orchestration workflow that is going to be done using the so-called vibe coding approach. I'm sure you all know already what is vibe coding. So the idea is basically zero manual programming. You just have an iterative, interactive conversation with an AI assistant of your choice. It produces the code. You put the code into your solution. You test it. You run it. You test it. You provide the results back to the AI assistant in case there is an error or something. The AI assistant needs to fix the code and tell you what to change in order to get an improved solution. So basically, zero of the code is purely manually produced. We wanted to check if it is possible to design a solution, so design the service, design the workflows and everything, and then produce the code that is going to run according to the design using an AI assistant. What was important to us is that the solution is not just supposed to work for a mini use case scenario or something, but it should be general and it should be standards compliant. So that means that we want to use the TM Forum APIs and the TM Forum Open Digital Architecture as the basis for the blueprint, for the service design, and for the workflows, and make sure that the solution is scalable. So that means it's modular, it is reusable, we can easily adapt the workflows to be used with the different types of service, for an example, not just the one that we have been testing on. So we don't just want a functional solution, we really want a solution that we can further build upon. Our approach was to create an environment that is going to be, of course, similar to Pioneer, but in lab conditions. For these purposes, we used the GP4L infrastructure in a virtual setup. So we used a container lab that actually creates a virtual image of the GP4L infrastructure with all of its devices. And then we used the approach of configuring this network the same way as we use it in Pioneer. So that means that we have a Git repository where we have all of the code for managing the network. The workflows are run by the Airflow workflow engine. The source of truth is MOT, which is one of the custom solutions that are developed by Work Package 6. And the way Airflow talks to the network is via LSO that actually is going to activate Ansible scripts based on Jinja templates to change the configuration in the networking devices. What we were focusing on when we say vibe coding approach and using an AI assistant is the first part here. So we are talking about the development of the service that is going to be represented in the single source of truth and the development of the workflows that are going to be running in Airflow in order to activate the Ansible scripts and do everything that is needed to provision a layer 2 circuit service. This is one of the first services that was developed for Pioneer as well. In the case of Pioneer, the Git repository, all of the code in the Git repository is manually produced by our team together with the team from PCSS. In this case, all of the code is supposed to be produced by an AI assistant. The first thing that we did, of course, was to choose an AI assistant. So we tried ChatGPT, we tried Gemini, we tried DeepSeek, we tried Microsoft Copilot with small examples to see what is the output, how good it is it easily creating, is it correct based on the inputs that you provide. And using these first kind of test trials, we concluded that ChatGPT is the one that is providing the mostly correct results compared to the others. So we chose this one as the AI assistant. So for the results that I'm showing you right now, we used ChatGPT, the version 4.0, as the AI assistant to which we were providing all of the specification for the code that we wanted to obtain. The way we used ChatGPT as an AI assistant was using this so-called loop of interactive conversation with the AI assistant. So that means that the human is writing a prompt in which he is explaining what he wants. This prompt is provided to the AI assistant. Based on the prompt, the AI assistant is expected to create a code that will become a draft workflow that is going to be then provided to Airflow, run a test on the virtual GP4L network and see if it works or not. If it doesn't work, then you get the error that is produced. You provide it back to the assistant, and then this is the new prompt. The assistant is reacting to the prompt, and he is giving you a new version of the code that is supposed to fix the error. And you do this loop as long as you want to refine the code or as long as you have an error in the code and so on and so forth. This kind of talking to the AI assistant was actually divided into two phases in order to obtain what we wanted. So in the beginning, when you start from zero, so you start with a blank conversation with the AI assistant, you are entering phase 1. And inside this phase, the idea is to basically first design the service that you want to implement, in our case, layer 2 circuit, and then design the blueprint of the workflow that you want to follow for provisioning of these layer 2 circuits. What is interesting is that during this phase, we were using so-called holistic prompting. This in our tests and everything, it turned out that it is the best approach. Holistic prompting means that you need to provide a nice, long, very specific, detailed explanation of what you want to achieve. For an example, here you have a sample of the text of the holistic prompting that we were using, where we say we want to develop a containerized software solution that allows users to create layer 2 circuits using a simple user interface, orchestrated Airflow, using MAT as the source of truth, Ansible for device configuration, and it needs to be compliant with the informed standards. What you say also is that you want the processes to be easily reusable for other services. So as you see in the phase 1, you give the AI assistant the big picture of what you want to achieve, and you give him all of the, let's say, constraints in the design that you want him to take into consideration. And this is very important, right? You need to tell him that it needs to be compliant with the forum. You tell him that you want to reuse this for other services, so it has to be flexible, it has to be modular, it has to be scalable. The input, of course, was much longer than this, but this is just provided here as an example to give you an idea that the length of the conversation, of the prompt, of the input that you provide here is much longer compared to phase 2. At the end of phase 1, what we got as output was design of the service. So how the layer 2 service looks like, combined with the forum. That means that we have the customer-facing service, the resource-facing service, the logical resources design, and the link to the physical resource that we have in our single source of truth. And the second thing, the blueprint of the workflow. That means all of the steps of the workflow, how they are connected, what is the input, the output of every step, how they are supposed to be provided to Airflow, in which files they need to be defined in order to obtain what you want. The code inside each of the steps is not defined. For the code inside each of the steps, you are moving on to phase number 2, which is development of the actual workflow logic. This phase 2 is designed using a so-called granular prompting. So in this case, the prompts that you provide to the AI assistants are much shorter. You focus on every step specifically. You talk to the AI assistant in order to make sure that in every step, the idea of the design is implemented. You test every step. If there is an error, you provide the error back in the loop until the step starts to work properly. What is interesting during this, let's say, exercise that we did is that we learned a lot about the process. The first thing that is truly usable, let's say, for all of us is that the AI assistant is actually very, very good at the phase number 1, which is service design and blueprint. So if you ask me after all of this testing and talking to AI and everything, I would tell you, yes, definitely use it in your design stage, because if you tell him it needs to be compliant with TMF, I want a scalable, reusable solution, you need to do this at the beginning, and then he really follows this idea and this logic in every idea and every solution that it provides. It knows everything about TM4. So if anyone sat down to read specifications about open digital architecture, about different APIs, open APIs that the TM Forum provides, you know by now that there are hundreds of pages that you need to go through. Some things are written here, some things are written there. Even people that are very knowledgeable about TM Forum sometimes have a hard time finding the information they would like to reference to when they're doing design. When you give the prompt to ChatGPT and you tell him, I want you to design a layer 2 circuit that is compliant with TM Forum, you don't give him any documentation about TM Forum, just the prompt, and that's it. He knows all of the documentation already. It's already part of his knowledge. So the design that he provides, it's always compliant with TMF. Every time we tried and tested and everything, it never made an error. And it can also explain to you why some things are designed in that way. So you can ask him in a prompt, why did you decide to create, I don't know, the resource spacing service like this? Or why did you make this resource as a logical resource? Why do I need to make it as a logical resource, and so on? And it provides a very good explanation, very, very nice explanation, and it specifically tells you about the places which should be done in this way just because you asked for the design to be scalable and reusable and flexible with other services. So for someone who is not very knowledgeable about TMF, it really helps to learn about TMF, and it really helps you while you're doing the design to check if it is TMF compliant and so on. During this stage, we also tried to give him a ready solution, so a service design that is done by us, by someone else, and for the assistant to check if this service design is compliant or it's not compliant, and to compare to his own proposal and to his own design that he has done with the conversation with you. And we got very good results. So he understands the design that is given to him. He can tell you right away which parts are compliant, which parts are not compliant. He can also discuss which parts are very good from a scalability point of view, which maybe could be done differently if you have something else in mind. He can also suggest to you improvements depending on what other types of services you have, what kind of flexibility you want for your customers, and so on. So it is really, really great for Facebook. The same thing happened with the blueprint of the workflows. So he basically suggests to you workflows which are following the TMF design of the process TMF framework for workflows, the high-level steps. And he's very good at granularing the steps into smaller pieces that are going to be defined into different files so that they are easily reusable in other services. And he is doing this, let's say, together with you. So it's not like you write a prompt and you get everything right away, but he's like a guide with you during the process. So he will stop and check and tell you, okay, do you want this like this, or do you want it in a different way? If you do it in the first way, you get this, this, and this. If you do it in the other way, you get this, this, and this. These are the pros, these are the cons. You choose and tell me how to continue. You need to give him input, of course, and then he continues in a way. He also asks you what is more important to you. Is resilience important to you? Do we need to think about security? Where is this going to be hosted? Are these containers together on the same network or a different network? So he takes into account a lot of things while doing the whole thing and while providing you with the solution. So during this process, you can, let's say, try to diverge from the initial idea. So you might, in the beginning, give him a prompt saying, I want a very flexible, scalable solution. And then you might make a decision to, I don't know, fix some parameter or something. So he's going to warn you, saying, like, if you do this, it's not going to be very flexible. But if you insist on doing it, like, yes, I want to do it this way, he's going to listen to you, and then he's going to do it like this, and this change is going to be correctly done in all of the code that is produced. Of course, every type you provide him with additional input during this conversation helps him create a better solution. When we came into the phase number 2, this is where the behavior was not so consistent and not so good as phase number 1. So writing the actual code and fixing the actual code didn't go as smoothly as the design and the blueprint phase, but it wasn't so bad. I mean, honestly, in the beginning, I expected worse performance than the one I got, so I was quite happy with the result. The code is okay as long as you are using, let's call them, standard components for your network management system. If you don't use a standard component and he doesn't understand how to use or how to talk to or how to interact with this component, this is where problems with the code appear. In our case, we had 2 very specific components. The first one was MAT, which, as I told you, is a custom solution developed by Work Package 6. And the other one is LSO. This is the lightweight service orchestrator, which is designed by the GÉANT team for orchestration and automation. For MAT, in order to be able to use the MAT in the code, because he needs to call the single source of truth to get information about the service, about the resource, update the information, link the information, and so on, right? He needs to call the API many times. You need to explain to him the API for MAT, because it's not something that can be easily found on the net, or many people are using it, and so on. So he didn't know about it. It was quite easy to explain MAT to the AI assistant by providing him with the JSON schema of the API. So we just provided 2 files, because MAT has 2 APIs, one for management of resources and one for management of services. With these 2 APIs, the AI assistant, ChatGPT in our case, learned how to use and how to talk to MAT using its API. And after that, there were no problems in the code every time MAT needed to be called about something. With LSO, we had bigger problems because LSO doesn't provide this kind of JSON schema for the API, and the documentation that we could only provide was the documentation that is provided on the site of LSO, and this was not really enough for him to produce very correct code when talking to LSO. So it really depends on how much the AI assistant actually understands and knows how to talk to the component. To give you a visual of let's say, a comparison of a human doing a pilot, a prototype of a solution, and manually, and doing it together with an AI assistant. We have here the results that we did. We basically had one of our team trying to implement the same layer 2 circuit for GP4L manually. And then I, on the other hand, was trying to do it using the AI assistant from ChatGPT in the case that we decided. Basically, the solution using ChatGPT was more effective in terms of time. It took me almost twice less the time than the time needed by a human to do it. It was more complete in a sense that, you know, when you're doing a prototype, programmers usually are not concerned about stuff like, is the workflow resilient? What is going to happen if you call the API of a component and it doesn't answer? Do you try again? How many times you retry? Stuff like that. Is it secure? Are you using basic authentication or tokens or stuff like that? The AI assistant thinks about these things from the start. So unless you tell him, I'm not interested in security, or I'm not interested in resilience of the workflow, the whole prototype solution that is going to be created is going to have all of this stuff from the beginning, which is not typical for, you know, fast prototyping when you try just to check if something works okay or not. From a modularity and structure point of view, again, when you tell him in the beginning, I want it to be modular, flexible, scalable, he gets this as an order and he doesn't forget it during the conversation. So even if you try to do something differently, if this is not the best modular solution, he is going to warn you and tell you, are you sure you want to do it this way? Because it's going to lose part of its flexibility and modularity. So from that point of view, he was excellent in all of the answers that he provided during the design and blueprinting phase. From a correctness point of view, of course, there were problems, but there are also problems when you do manual programming, right? But in case when you're using an AI assistant and you're doing a full vibe coding deal, then of course the number of problems is going to be higher compared to the manual approach. So it is quite good, but you know, you cannot trust him 100%. Here are just some examples of how he talks to you and how he guides you through the process, just to give you an idea of how it looks like. It's quite good for people that are new to orchestration and automation, that are not still deciding on what to do during the design process, or would like to learn a little bit more about something before they make the decision. It really helps you with the output. For an example, if you tell him, I want processes that will be easily reusable for other services, right? He creates the so-called orchestration philosophy that he is going to then implement in the code. And as you see, it's quite good. I mean, he thinks about all kinds of aspects of reusability. And sometimes it happens that, you know, we forget about something that he will remember. So it's good to at least use him as a consultant if you don't want to use him in a full vibe coding mode. He can also tell you how can this be reusable, how can the solution for an example, layer 2 circuit be reusable for layer 3 VPN, and how during the design phase and the ideas that he's giving you, he's actually implementing this kind of behavior. This is, for an example, his initial idea on during the blueprinting of the workflow, so of the files that he's recommending for all the tasks of the workflow process, and the way he's granularly defining the workflow, which is not always the case when you're, for an example, implementing a workflow as a prototype. That's why we say that he is much better at modularity and scalability compared to a human programmer. Because, you know, at the beginning you said, I want it modular as a design goal, but as you go through the prototype, you kind of try to do it as fast as possible and you forget about this. He doesn't forget, so that's why it's nice to use him for these kinds of guidance. One of the interesting ideas that he gave us was, for an example, the interaction with the single source of truth, math in our case, to be implemented as a math operator. This is a special type of implementation of Airflow talking to an external component. The interesting thing is that in our implementation for the Pioneer network, initially we didn't have this implementation done in this way. We used a different coding approach. But then when we got this output from ChatGPT and we investigated it a little bit with this vibe coding solution and everything, the team decided that this is actually a better approach and a better solution. And this new version that is currently running in production for Pioneer is actually using an operator for the interaction with math. So it can actually help you become better even if you started with a manual development of the code. As I mentioned before, it is very good that he can learn about custom components when he has nice structured input about them. So this is the example where we provide him with the 2 JSON schemas for the API of math. And when he processes these documents, he basically knows how to talk to math and how to generate correct APIs when he's interacting with math in order to retrieve or to change or to delete, to create information regarding resources and services. This is another example where he constantly reminds you about stuff such as resilience of the workflow, such as security of the workflow, such as the auto retry logic and everything that we, on the other hand, constantly forget about doing when we are doing prototyping and initial implementation of some kind of services. Another thing that is interesting for me while we were doing this is that there are a lot of tips and tricks, right? How to do prompt engineering. Prompt engineering is very hot topic right now. You need to learn prompt engineering. There are some interesting results from there. For an example, I didn't know before that if you write rude prompts to ChatGPT, you will get more correct results comparing to polite ones. I mean, the difference is something like 88% versus 84%, but if you're talking to ChatGPT, maybe try it once and see if it works for you. We showed in our use case that it is true that if you ask for a structured reasoning plan before the code, it works quite well. So in the design phase, you start this process where he guides you through everything. So you use this structured chain of thought and you control him in every step. You do every step together, and it is much better than just telling him, okay, now give me the whole code at once and that's it. And that's why almost everybody is telling in all of the papers that this session, the loop session of planning, acting, verifying, so testing, providing the error, actually works the best with this kind of AI assistant. We tried this last thing as well, and it works quite well. So you have a solution, maybe you have a manual solution, or maybe you have a solution that another AI assistant created or he created before. So you feed the solution back to him and you ask him to criticize it, to find the weak spots, to suggest improvements and so on. And he is able to do that and to really find the places where, for an example, scalability can be improved and so on. So it's quite interesting to use it in that way as well. Of course, prompt engineering is really something that you need to learn, right? So in the beginning, if you haven't done it before, in the beginning, don't expect that you will get magic right away. You kind of need to learn how to talk to him. One of the things that you need to remember is that you need to provide detailed information about what you want. So when you tell him, I want this, and this, provide all of the details that you can. Don't forget anything, because everything that you don't tell him, he needs to assume. And if he assumes too many things, he is going to start to hallucinate. And this is where hallucination happens. So hallucinations happen in order to fill the holes that you haven't provided. So if you provide enough detailed information, then the probability that what he provides you as a solution is going to be good and really usable in the way that he provides it is quite very, very high. From time to time, if you get stuck on a detail or something, he might start to become delusional. He's going to diverge from the main goal of your project, of your conversation. It doesn't happen very often. It happens less frequently, but when it happens, we've tried many times to get him back on track towards the goal that we had initially, and it doesn't work. So for now, my tip and trick for you is, if this happens, you better start over. So you better start a new conversation from the beginning, try to provide in prompts details about everything you've done so far, and then try to continue, because he doesn't react well when he starts to diverge, to get him back to what you did. So in the end, how you can use it? Well, you can use it if you want an ultra-fast design. It's going to be great. You expect that the design will be very close to what you need and what you have, and you might just need to polish it up a little bit. So you can get a prototype with all of the functionalities and everything quite fast. And it is very, very great for people that are less experienced in the design and implementation stage. So for a programmer that is learning about automation, orchestration, it's a godsend, right? And even if you have a person that needs to write code about Airflow and they haven't used Airflow before, they don't know about Airflow, anything about Airflow and so on, using an AI assistant can actually help them a lot, and they can achieve a lot in a very small window of time. In this way, he can actually reduce the amount of work from days to even hours sometimes. So it will be really, really ultra fast. But you need to be detailed, and you need to ask for a standard compliant solution. So you need to give him very good frames inside which he needs to work. So reduce the hallucinations to minimum. What we are doing now is we try to do these kind of workflows with AI, but in a dynamic way using AI agents. So the idea is not to have the workflow static, but to change depending on the situations inside the network and everything, which is basically a continuation of this, where we have a more challenging environment inside which we need to work. We also want to try to use this kind of approach for multi-service, for multi-domain workflows, and in the end, to have this kind of adaptive AI that is actually going to learn from our corrections. Because right now, if ChatGPT keeps making a mistake about something, you cannot really teach it. I mean, we've tried to tell him, okay, you don't do it this way. You need to do it in this way. And he tells you, yes, okay, I will. And then he doesn't. So don't waste time on trying to teach him. Currently, it doesn't work. Maybe it will work in future versions. That's all I have to share with you for now. Stay tuned for whatever next we have on our agenda.
Today, I will introduce you to an incubator project that was implemented in the previous months. It was completed in October. It is LogsLLM, which stands for Automated Log Analysis and Management with Large Language Model. So, so here's the agenda of my presentation. Well, we will address the background and the problem that we try to solve, what LogsLLM does, how it can help NOC and NetRuns, the high-level architecture stuff, some case studies, and of course some evaluation results and future work. So first of all, here are the partners of this initiative. I'm from NTUA. The other partners are GRNet, PCSS, and SINET, where we collaborated in order to implement our solution. So, regarding the background and the problem statement, first of all, AMRES and NOCs deal with massive heterogeneous logs as you are aware of from various monitoring services and other stuff. These logs are unstructured with inconsistent formats. It is also hard to normalize and correlate these kind of logs, and of course they require expert interpretation. So based on this issue, and of course we also saw that the traditional tools that are used for logs analysis are rule-based, rigid, and with limited adaptability. We tried to create a solution that could unify some of these logs in order to have it in one place and to be and to be better analyzed. So, what LogsLLM does? First of all, we try to standardize heterogeneous logs in the unified structured format. In our case, we had logs from Firewall, from Isinga, from Netbox, and at Uptime Kuma from NMAS. So we had to, to design a unified schema that could be applied to these different logs. After the standardization procedure, our next step was to have a mechanism that could detect anomalies and correlate related events across systems, and to generate insights in natural language to support NOC operators. So the outcome of this solution is a faster incident understanding, reduced manual analysis, and consistent explainable log intelligence. And our main concern was to have a tool that, of course, could help NOCs and endurance on daily NOC operations. So based on our solution, we can have a faster response to various incidents that can be found in these logs. We can have a mechanism that can be on-premise, so we can have privacy and integration based on our solution, better awareness for different various incidents, less manual work, as I mentioned before, and of course, the knowledge sharing, where NOC operators can share the outcomes of our solution, and of course could be also trained on how they can handle these incidents. So, regarding the high-level architecture of our solution, first of all, we have the data ingestion layer, where we have Firewall, Isinga, Netbox, and Uptime Kuma logs from the NMAS platform. When we had this data anonymized, of course, we utilized a first agent which standardized these different logs. Our the scope of this agent was to transform the raw logs into the unified schema that we created. In this unified schema, of course, we had some fields that were necessary. For example, a timestamp, the service, some of the IPs, anonymized, of course, and other stuff. But also we had some optional fields made based on the different logs. For example, some fields that could be found in the firewall logs were not available on the Isinga or the Netbox logs, and vice versa. So after the standardization procedure, we had these standardized logs stored in an SQL database. In our case, we used a Postgre SQL with JSON schema. that we had for each log. And this dataset was used as the input for the analysis. This was done via the second agent. This agent tried to detect anomalies, correlation, and summarize the logs output. But I think that the main aspect of our solution was that we didn't try, how to say, to train our models from scratch, but to take advantage of the prompt-driven reasoning. So our agents were not trained with data. We just had prompts that could be easily modified based on our needs. As a result, we can have a solution that can be scalable and can be, how to say it, more flexible in terms of adopting new log types, especially in the standardization agent. This could be really helpful. And we had the whole mechanism based on fast API endpoints in order to have something that can be scalable, of course, and to have something that could be also secure. So that was for in terms of the high-level architecture. Before I will continue, just to clarify here that we tested our solution with 3 different LLMs. We used a ChatGPT 4.1 version provided via AWS and Azure OpenAI service. These services were in regions in Europe, so there were also GDPR compliant as well. And we also tested our solution with, how to say, small language models like Llama or like DeepSeek in our case, with a minimum billion, with how to say it, with small billion amount parameters. For example, in Llama and DeepSeek, we just use models with 7 billion parameters. So we try to check if our solution can be used in with models that can be easily run on a non-premise infrastructure. In our case, the on-premise infrastructure was at PCSS, where we had an A100 NVIDIA GPU card in order to make our experiments, and we also saw that the results were moderate in our case, so we can even use small language models in this case. And here we will see some case studies from our solution and how it can be easily utilized in a daily NOC operations routine. First of all, we have a case study for security monitoring. In our case, we have some firewall logs. As we can see, we had a dashboard with where we can have a first view of our data. We just had to pick a time frame in order to make an analysis on our data. As you can see, we had, for example, data and for a specific day from 19th of March to 22 of March in our case. We had for 4 days. These data were, of course, visualized. And as you can see, we had also in this in this visualization, we also had a small interpretation by the model itself that there was a significant spike on activity on a specific day. But of course, this was just a first step of our solution. We had a ChatGPT based front end where NOC operators were able to make specific questions about specific time frames. So we had, in our case, a question about these activities. So in our case, we had the answer that, okay, I have found some specific connection denied and connection blocked events. We also checked other cases as well. We have some spikes in the firewall data. And we checked this procedure with 3 LLMs that I mentioned before, ChatGPT 4.1, Llama, and DeepSeek. The second case was a cross-system correlation and root cause exploration. As you can see, based on a specific time frame in our case, we just asked the model to identify relationships between service outages and firewall blocks for the same tenant or host. And of course, it provided for all the services if there was any correlation between all of 4 of them services. And we had, for example, for firewall blocks, and as we can see in the answer, it was found that were about 500 connection blocked events and connection denied. We also checked the destination IPs if there was any correlation between them, so we could easily check all the logs to see if there was some kind of correlation, and of course to have a root cause exploration of what happened, and we had also these results. Another case study that LogsLLM can be used is the configuration and asset insights, which is related to netbooks, where we could summarize the bulk changes on core devices or key IP ranges or netbooks, where we have an answer based on our data. Other case studies, an on-demand incident review and reporting, where we have, of course, some filters. In our case, we checked the firewall service, and we could easily generate an on-demand incident report where we had the impact and the likely cause. For example, in our case, the impact and the likely cause were, provided as terms in our prompt on the model. So we were specific on what we expect on these fields. For example, the impact and the likely cause. Finally, LogsLLM can also be used for training and knowledge transfer. For example, based on logs that we already have from our monitoring services, we can check, for example, if why is this netbox change, for example, is potentially risky, where LLM can provide insights on why on a specific time frame a change can be risky, or of course we can have more generic questions. So it could be easily used for a junior NOC operator and can learn more from specific cases, and that of course we found that where we had malicious traffic. Next, we have the evaluation of both agents that I mentioned before. As I mentioned, our intention was to check if we can have some moderate results with small language models, and not to stick with open AI solution. So our goal was to assess how well the first agent converted heterogeneous logs into a unified schema. In order to have this evaluation, we checked 3 dimensions: the detection, if in that case the detection was if our solution can recognize and classify events. For example, if the events were from the firewall or were from uptime Kuma and other stuff. The accuracy, if the fields were correct and consistent, that were stored in our new schema. And finally, the utility, if the results were informative for operators, because we had some fields like comments and other stuff that where these logs were interpreted by our model. So in our case, we had the 4 datasets from a single networks, uptime Kuma and firewall. The models tested that I mentioned before, and all models use the same schema and prompts. Keep this in mind, because in the results we show that, for example, DeepSeek was not so accurate in our case. As we can see in the results, we had a detection average on ChatGPT 4.1 mini and Llama 3.1, where can be considered good in our case. The accuracy was fine for all the models, and the utility, we had better results with ChatGPT 4.2 mini. One of our findings based on our solution was that in the DeepSeek, we had to check with different prompt techniques. For example, few shot mechanisms and other stuff was not working as expected in DeepSeek, but as we had to evaluate the models in the same prompt, we also had to check it with DeepSeek as well, with the same prompt that worked for the other 2 options. Regarding the evaluation of the analysis agent, was the second agent of our solution. The setup was to have 4 representative cases: spikes, cross-source correlation, device IP attribution, and configuration impact. The models were the same. We had 10 runs per model per case with identical parameters. We had a small temperature, as we wanted a model that was relatively strict and with specific max tokens in our case. The metrics were objective, for example, claims accuracy, severity match, and inter-run stability. And in that case, we also had a human evaluation mechanism in order to evaluate the results of the analysis. So we used grading system from 0 to 5, and we examined 3 major fields of evaluation. In our case, we had the usefulness, the clarity, and the trust. So the results of this procedure was regarding the claims accuracy and the other metrics were, how to say, overwhelming for ChatGPT 4.1. But as we can see, Llama was also good in some metrics. For example, the severity match was absolutely fine. The usefulness and clarity and trust were the metrics that were were utilized by network operators. were also fine. For example, the Llama 3.1 has a usefulness almost 4. The clarity and the trust are also good in terms of Llama. So we see that even with small language models, we can have moderate results. And to conclude for our case, first of all, LogsLLM was a proof of concept for LLMs in log management. That was our intention, and we think that we can check, of course, more data sources and more techniques and models in order to see if we can utilize more models in our case, or even more agents. It was a multi-agent approach in our case. This approach shows strong potential. We didn't have one agent for all. We have multiple agents, and we could even split some agents. For example, the standardization agent would also be split, or even the analysis agent. We could have more than one agent. This approach was good, and we have good results as well. Our solution can complement existing monitoring tools as a way to, to gather logs from various monitoring services. And of course, it can be used for future AI-powered NOC operations as well. And regarding the future work from our side is to instruction tune Q&A over logs, to have reinforcement learning from human factor for improved accuracy. We saw that this mechanism worked because, of course, we were able to improve even our prompts. I think that in the next steps, this mechanism can be used for also to train our models if we not stick with prompting. A real-time alerting integration is also something that we have in our case as a next step. We already have a mechanism, but it's primitive, so we can further improve it. And finally, to have a broader deployment across GÉANT and NMAS as a way to test our mechanism and to improve it on a continuous basis. Thank you.
I am Isabel Gandía. As Ivana said, I am the service manager for the Network eAcademy, and I'm also leading Work Package 6 in GN5.2. Let's try to go ahead with this, and please try to reach me somehow if I stop being here. Okay, so the Network eAcademy, as you probably know, is an umbrella of activities. We are here to help you. We are producing different resources that started around automation, and they are grouped under the Network eAcademy umbrella. And this includes 3 training programs, a common terminology document, a reference, functional architecture based on the TM Forum Open Digital Architecture, an OEV maturity model, and also promotion of orchestration, automation, and virtualization activities. And what started as orchestration, automation, and virtualization all of a sudden became also something that had to do with artificial intelligence, because you were doing network automation. We want to use artificial intelligence. The Network eAcademy, you have the link here, just you will have the slides later on the website, on the Infoshare website, so you will be able to go to any of the training tracks or to the maturity model if you want to fill it in, or to the architectures if you want to map your own architecture or see the terminology documentation. And just let you know also, we are working on terminology documentation for artificial intelligence. This is the training portal. This is also the link to the training portal if you want to go directly, and it will be on the website after this presentation. And if we focus on network automation, you have heard Sonja talking about the TM Forum, Open Digital Architecture, or the TM Forum before, because what we're doing is following a little bit this structure. This is a functional structure, high-level one. Don't plan to have blocks with the names of the tools there. It's a functional architecture. And what we did when we started the training on network automation, on orchestration, automation, and virtualization, was to follow this functional architecture. The Open Digital Architecture has these blocks you see here: engagement management, party management, core commerce, production, intelligence management, and all the coupling and integration in the middle. I'm not going to go into the details of that. There are info shares specifically about architecture. I'm going to focus on intelligence management today because this is where the artificial intelligence is going to help us best. If we go to the map as we had it when we started with this, not when we started, just a couple of years ago. 2 years ago, this was a map for the orchestration, automation, and virtualization. And as you can see here, the colors are tied to these big blocks in the TM Forum Open Digital Architecture. So we had an intro line that was crossing all the other lines because it was important to have an introductory view for those who didn't want to go in depth into the details of any of the tools, but wanted to have knowledge on automation for networking. And you see there is a fuchsia line here, intelligence management. This one is the one that I'm going to focus on now, because just 2 years ago, and it looks like time is flying, but just 2 years ago, we only had this in the intelligence management section. We were talking about an introduction to intelligence management. We already had published a unit on towards intelligent networks, and our maturity model already included using artificial intelligence in some cases. But we were not really talking about artificial intelligence tools. We were talking about a little bit of big data, data analysis. We were planning to publish things on streaming telemetry, Elasticsearch, Persona, things that have to do with looking at the network, looking at our logs, our information, and putting some intelligence in there. But if we look at this same map as it is today, this is the map as we have it now. As you can see, the map has grown a lot in the intelligence management section. This fuchsia line is now enormous. Why? Because, you know, artificial intelligence has really exploded and we have it everywhere. We want to use it everywhere. We already included some things there. For instance, we have all the information from the So Big Data Academy for data analytics. Also, we have this introduction to artificial intelligence. We have published a unit on unsupervised learning, a unit on neural networks and deep learning. We have several units published. This map already has something missing, sorry. But we started doing something when we saw the artificial intelligence was really taking off. We started in January 2024 to define this intelligence management section that you have seen that is so big now. We added some units to the intelligence management line and decided on a two-phased approach with an initial focus on introductory units and then more in-depth units. There is a whole section on intelligence management now, which is closely related to AI. Then we put this focus group to sleep. It was dormant after defining the units. And also in the previous project, as Pavle mentioned before, we worked on an incubator project on a chatbot for training. Currently, what we are doing is to rethink this because we had already made this intelligence management line longer to include more units, but the map is completely crowded right now. And the interest around AI relevant topics is increasing more and more. So what we are going to do now, just for you to know, we're working on it. We are detaching the AI section of the network automation map on the part of the intelligence management. We are working on the new map with two introductory paths. One of them is to understand how AI works, the introduction to AI to understand, well, I will show you the draft map right now. And the second one is to have AI as a tool. to use AI to manage your networks, a little bit as we have seen in the previous presentation. We're following the FCAPS framework, fault configuration, accounting, performance, and security. And so the map right now, this is the last draft version we have been working on, is this. As you can see, there is this green line, the introduction to AI, where you can see all these units from predictive AI to generative AI, going to autonomous networks. And on the bottom side, we have this red line with AI use cases following these FCAPS blocks, let's say. What we have published so far is what you see here. We have published the intro to AI, the unsupervised learning, the neural networks and deep learning, the data mining and ML with so big data, and also the document that you have been, in some cases, collaborating on, the intelligent networks, the rise of generative AI in network management, which will be included also as a document in the map. We're working on several units. Let's say our group of trainers, some of them are here. Thank you very much for your work. This group of trainers is devoted to working on artificial intelligence units. Right now, we're working on all the units you see in orange here. From AI for terminology extraction, because we're working on this AI terminology document, and the document here will also be, should be also be in orange. And then we have data processing and exploration, model evaluation and metrics, linear and logistic regression, reinforcement learning, the introduction to explainable AI, and also prompt engineering, chatbots, and conversational AI. And after watching Sonja present, maybe I will ask our trainers to be rude to the LLM and to ask things in a rude manner to get better responses. I know we will need to talk about that. In any case, you can see here that our plan is to publish many units on artificial intelligence to understand how it works and also the use cases. And they are not going to be published necessarily in this order, because as soon as the trainer finishes one unit, this trainer is going to start working on a new one, and it can be on the use cases. We have a lot of interest in the prompt engineering and the chatbots and conversational AI, and to have use cases that can be applicable to your networks. So stay tuned for that, because we plan to have this. And also, if you have any ideas or you have more, let's say, examples that you would like to see or would like to use, please feel free to approach us, contact us, or even send us your information, and we will be happy to discuss this with you and see how we can collaborate. We are also, as I said, working on this terminology documentation on new, we have a document that we already published, and it was a document for orchestration, automation, and virtualization. But in this case, it's going to, we're also going to split this, because we have a lot of terms and some other topics that should also have their own terminology documentation or their own dictionary. So we are now working on an artificial intelligence document on this section. And of course, we have used artificial intelligence to create the document, to find the words, to see how frequent some words are in some of the texts we are currently using on our units, also to find or to extract abbreviations, things like that. And we just included here some of the tools we have been using, because it can give you some hints in case you want also to use them. Also, we have a working group, the GNAG Network eAcademy working group. We have held so far 3 open monthly meetings, and it would be good for us also to have you in the next one. In the first open meeting we had, Bojana Koteska talked about the presentation, talked about the 2 recently published units. And on the 12th of November, we had the presentation on terminology, where Jacobo Ziono mentioned this new document on AI and machine learning and the usage of AI to find terms. And on the 10th of December, we had a presentation focused in this case on architecture analysis, and Lydia Jakovic presented on the recent architecture mappings we have done. The next meeting is on the 11th February. We skipped January because of the Christmas break, but you're free to register here and to follow the next meeting. We will probably talk about quantum, about OTFN, because we are also changing things there. So stay tuned for this. What else can you do? You can follow the training tracks, you can map your architecture, you can also have follow the maturity model and do a self-assessment. We would be happy to help with that. If you want to see your example in the community portal, also feel free to send it. See a terminology and glossary, subscribe to the mailing list if you want to participate. You see there are many links. I see Ivana is also sending them. Thank you, Ivana, for that. Just as a summary, contact us, share your ideas, share your suggestions. Let us see if this is useful for you, or if you prefer to have a different approach for any of the units. And of course, we'll be happy to talk to you about that. And that would be my presentation for today. Thank you for your attention.